This is section 2.5, part 3, where we need to tell if the equation represents direct variation. So in order to do that, you need to remember direct variation takes the form y equals ax. And remember, y equals ax, a kind of is this x similar to slope, where it's a constant rate of change. And with direct variation equation, if you remember, direct variation always passes through the origin. So it passes through 0, 0, so it has a y-intercept of 0. Alright? It's important to remember, and if you remember that, it will help you identify direct variation equations pretty easily. So I've got the first example down here, and we can see it's y equals 3/5 x. So you really want to ask yourself, is this in the form of y equals ax? And if you need to, you can write the equation underneath and see y's match up. My a is represented by 3/5, and I have an x. So it looks like, yes, we do have a direct variation equation here. So you can either simply write yes, or you can write that direct variation does exist. That's the easiest. Alright, the next one, alright, we can see, well, I'll scroll down, you can see the next two. Alright, neither of these two equations are solved for y. So in order to tell whether or not you have direct variation, y needs to be alone. So you always want to solve for y. So I'm going to do that in number 2. Alright, we want to get y alone here. So I'm going to divide both sides by 4. And I can see I've got y equals 2/4 or 1/2 x, because the 4 is canceled here. Is this direct variation? Does it take the form y equals ax? And it definitely looks like it, and it looks like my value of a is 1/2. So again, yes, this equation represents direct variation. Okay, let's go down and look at number 3. Alright, where we've got negative, or 2y minus 10 equals 16x. Again, you want to solve for y, get y alone. It's going to take 2 steps. So I'm first going to bring the 10 over. So I'm going to add 10 to both sides. 10's cancel. Drop down my 2y. So I see 2y equals 16x plus 10. Now I'm going to divide both sides by 2. 2's cancel. And I see y equals 8x plus 5. Is this direct variation? Well, we know the direct variation equation is y equals ax. I've got my y's. My a is represented by 8. I have an x. But notice I've got this plus 5 over here, where we know direct variation is supposed to have a plus 0. So whenever you have a y-intercept that is not 0, you do not have direct variation. So your answer is not direct variation, or no. And again, it's because we don't have a y-intercept of 0. Right? It's not in the y equals ax form.